All right, here we have this exponential function, f of x equals 1/3 to the x power. And we want to sketch the graph of this guy. First of all, we know that this is an exponential function because the x is in the x is in the exponent, right? Okay, so that's what makes it an exponential function. This is not a polynomial function. Okay. So let's just make a table, right? Let's make a table of values and sort of see what happens with the graph. Okay. Also, you should know what the general shape of an exponential function is. Okay. So let's just plug in 0 here. Notice what happens when x is 0, right? 1/3 to the 0 power. Well, anything to the 0 power is just 1. Okay, so we get a 1 here. But notice here what happens when we put x is equal to 1, right? We get 1/3 to the first power, which is just equal to 1/3. But what happens when x is equal to 2? Right? It's 1/3 to the second power, which is 1/3 times 1/3, which is 1/9. So you notice, well, wait a minute, as x gets larger and larger, my y values are actually getting smaller and smaller, right? Okay. Now, what happens when you plug in a negative value of x, like -1? Right, here, I'm actually going to write it out, right? We get 1/3 to the negative first power. Okay. But wait a minute, what does that negative exponent mean? It means that we have to take the reciprocal of the base and then raise it to the first power, right? Well, what is the reciprocal of 1/3? Right, it's 3 over 1, which is just 3 to the first power, right? What about when you plug in x equals -2? Right, we get 1/3 to the negative second power. But once again, that negative exponent tells us let's flip this number over. So the reciprocal of 1/3 is 3, right? And then we still have to take that second power here, so we get 9. Well, take a look at the graph, right? What is this graph going to look like here? So we'll draw the x values here. Okay. So you notice that when x is equal to 0, y is equal to 1. Wait a minute, but when x is equal to 1, y is 1/3. We get 1/9, 1/27. So these y values keep getting smaller and smaller and smaller, right? But what happens on the other side here, right? When x is equal to -1, y is equal to 3. When x is equal to -2, y is equal to 9. Okay, so this graph, what is this graph doing? Okay, it's going to essentially do something like this, right? Now, we don't actually never touch the x-axis here, right? Okay, so we'll just draw an arrow to mean that the graph continues on forever to the right. You notice, though, there's something very special about this graph, right? This is the reflection, right? This is the reflection of the graph of y is equal to 3 to the x power. Okay? So these are just reflections of each other. Okay? Now notice another way to write this, right? We can write this as 3 to the negative x power. Okay? So this is the graph of 3 to the negative x power. Right? So this is the graph of 3 to the x reflected across the y-axis.